All right, today we're going to be learning about how to rationalize the denominator. There's two more rules for a simplified radical. You can't have radicals in the denominator. Which you should have learned a little bit about in previous math classes. And then another rule is that there can be no fractions or decimals as the radicand. And if you recall from a couple of classes ago, the radicand is the number underneath the radical. So in previous lessons, we've been able to simplify these by dividing the numbers underneath because they both have the same root. So the square root of 20 divided by the square root of 2 would equal the square root of 10, which we cannot simplify any further. The cube root of 16 divided by the cube root of 2 would be the cube root of 8, which simplifies to 2. And the fourth root of 81 divided by the fourth root of 3 becomes the fourth root of 27, which we also cannot simplify. But what do we do when we get to things like the square root of 10 over the square root of 3? 10's not divisible by 3, so we have to rationalize the denominator. What number can we multiply by and have it not change the number? Hopefully you said 1. So we need to do something about this square root of 3, but we can't change the overall problem. So we can't just square the whole thing. That would change the problem. What we can do is multiply by the square root of 3 over the square root of 3. Multiply it on top and on bottom. Because the square root of 3 over the square root of 3, if we divide that, square root of 3 divided by square root of 3 would equal the square root of 1, which is just 1. So technically, we're multiplying by 1 here. So if we multiply this across, square root of 10 times square root of 3 is the square root of 30, over square root of 3 times square root of 3 is square root of 9, and then simplify. Square root of 30 can't be simplified. Square root of 9 is 3. We no longer have a square root in the denominator. It's fine that we have a square root on the top. So if we have the square root of 3 over 5, that would be the square root of 3 over the square root of 5. But we can't have the square root of 5 in the denominator, so we multiply top and bottom by the square root of 5. We get the square root of 15 over the square root of 25. And when we simplify, we get the square root of 15 over 5. And just a friendly reminder, for both of these, we can't simplify and say, oh, square root of, we got 30 over 3, that simplifies to 10. You can't do that because the top has a square root and the denominator does not. Same thing here. Can't divide the 15 and the 5 because the 15 has a square root and the 5 does not. So the next example, we have the square root of 10x on the bottom, so we're going to multiply top and bottom by the square root of 10x. The 2 does not have a radical, so it's just going to stay out front. Square root of 10x over the square root of 10 times 10 is 100. X times x is x squared. If we simplify the denominator, we get 2 square roots of 10x over 10x. Is there anything else we can simplify? Yes, there is. 2 over 10 can be simplified to 1 over 5. So we get the square root of 10x over 5x. In this example, we have square root on top and square root on the bottom, so we can simplify. 5 and 30 are both divisible by 5, so we can simplify this to the square root of 1 over the square root of 6. Then we need to get the square root of 6 out of the denominator. So multiply top and bottom by the square root of 6. Get the square root of 6 over the square root of 36, which simplifies to the square root of 6 over 6. Now what if we have a little bit more going on in the denominator? Here we have 5 plus the square root of 2. Let's see what happens if we just multiply top and bottom by the square root of 2. On the top we get 3 square roots of 2. On the bottom we'd have to just, what did I write 3? On the bottom we'd have to distribute the square root of 2, so we'd end up with 5 square roots of 2 plus the square root of 4. Now the square root of 4 would simplify to 2, but then we'd still have this square root of 2. So we need to do something a little bit different. In this case, we need to multiply by the conjugate. And we've talked about the conjugate in a couple previous units. And if you recall, it's the binomial with the opposite sign in the middle. So we're going to multiply top and bottom by 5 minus the square root of 2. On the top, we're going to distribute the 3, so we'll have 15 minus 3 square roots of 2. And on the bottom, we're going to have to double distribute. So 5 times 5 is 25. 5 times negative square root of 2, which is 5. Negative 5 square root of 2. Square root of 2 times 5 would be plus 5 square roots of 2. And then minus the square root of 4. The top cannot be combined or simplified at all. In the denominator, negative 5 square roots of 2 and positive 5 square roots of 2 cancel out. We're left with 25 minus the square root of 4 is 2. So we have 15 minus 3 square roots of 2 over 23. Now, we can't in this case, but if 5, 3, and 23 were all divisible by the same number, then we would simplify our fraction more. But since they're not, our final answer is 15 minus 3 square roots of 2 over 23. So let's try it again. We're going to multiply by 1 plus the square root of 5 this time on top and on bottom. Distribute on the top. And double distribute on the bottom. Square root of 2 and square root of 10 can't be simplified. They also can't be combined, so we're just going to leave it square root of 2 plus the square root of 10. In our denominator, the square roots of 5s will cancel out. On the bottom, we're going to have 1 minus the square root of 25 is 5. So we get the square root of 2 plus the square root of 10 over negative 4. Now, one thing we have to be careful about here is the denominator is telling us how many pieces we're dividing something into. Does it make sense to divide something into negative 4 pieces of something? Like, could you make a pizza and make it into negative 4 slices? No, that doesn't make sense. So what we do is we divide both things on the top by negative 1 to move the negative from the bottom to the top. So we're going to end up with negative square root of 2 minus the square root of 10 all over 4. Now what if we have an imaginary number in the denominator of our fraction? These are also not simplified. We know that I is equal to the square root of negative 1. So technically, these have a radical in the denominator. Also, if you think of our pizza analogy, how are you going to divide a pizza into an imaginary number of slices? That doesn't make sense. So for these, the problem is the I here. So we just need to multiply top and bottom by I. If you chose to multiply top and bottom by 2I, it's also going to give you the same answer in the end, but you're going to have more simplifying to do. So 3 times I is 3I over 2I times I would be 2I squared. We need to simplify the I squared, which we know is equal to -1, so that'll make this denominator -2. And then remember, we don't like negatives in our denominator, so it'll be -3I over 2. This next example looks similar to these two previous examples where we have a binomial on the bottom. So just like those, we're going to have to multiply top and bottom by the conjugate of the denominator. Double distribute on the top. 7 plus 28I plus 5I plus 20I squared. And double distribute on the bottom. 1 minus 4I plus 4I minus 16I squared. We know our I squareds are going to change to -1, so we'll have 7 plus, we can combine these, and get 33I minus 20 over 1. These cancel out. -16 times -1 become +16. So we end up with -13 plus 33I over 17. That's all for today. See you in class.